The time value of money is an idea which follows this philosophy. A dollar today is worth more than a dollar tomorrow. It's the same idea as we have been applying recently while we worked with compound interest. This is our compound interest formula, right? Where A, the amount of money we have at any given time, is equal to P, a principal investment, whatever we start with in our investment, times 1 plus our annual rate, divided by the number of times we compound that rate. We apply that rate per year, all to the power of that same number n times the number of years t. This was very useful for us in calculating the amount of money that might be in a savings account or any other type of investment which accrues interest after a given amount of time, right? So for example, we have the following problem. It says, Mr. Hobart invests $1,500 into a stock portfolio, which accrues 6% annual interest compounded monthly. He withdraws his money after 5 years. How much value has his investment gained? So we need to calculate A here, right? So to start with, A, we don't know. We don't know how much money it's worth after 5 years. We do know I started with $1,500, so that'll be my principal investment. We also know that my interest rate was 6%, that is 0.06, over the number of times we compound per year. This is monthly, there's 12 months in a year, so we divide by 12. All to the power of that same number 12 times t, 5 years. Now if I plug this all in to a calculator, I would get $2,023.28. So, but the question asks us, how much value has my investment gained, right? So my initial investment was 1,500. So let's subtract these. And we'll see that we've gained $523.28. So that's compound interest, right? Now, the thing with compound interest is that we are investing some principal amount, right? We just put some money away, let it sit there and gain value. But that kind of leaves us with the following question. What if I don't leave the money, right? What if I continue to invest in a fund as it gains interest, right? So suppose instead of investing $1,500 right away, I just put away $100 per month instead. So I throw this crisp $100 bill into my bank account, and after 1 month, you know how much money I have? I got $100, right? Because I put $100 in this month. Boom. Now what about the second month, right? Another month passes. My $100 is still in my bank account, correct? But it's going to gain that 6% annual interest compounded monthly. Now, the interest rate that we're gaining is really 0.06 divided by 12, right? So that's going to be the equivalent of 1.005. So I'm going to have 1.005 times my investment from the first month, right? But guess what? It's a new month. I'm going to add another $100 because I have decided that I'm going to be putting away $100 every month. Well, 100 times 1.005 is 150 cents, $100.50. 100.5 plus the other 100 I just invested would mean that after 2 months my account is worth $200.50. Interesting. Let's see how this works when I throw it into the third month. Now, in the third month, I am going to start with my 250 or $200.50, right? Right here. This is in my account right now, right? Well, guess what? That, oh, all right, I may not have copy pasted that very well. You'll have to excuse me on that one, guys. All right. So I have the $200.50 in my bank account, but that will accrue interest, right? That $200.50 is going to be multiplied by my monthly interest rate, which is 1.005, right? Distributes. And not only did I gain interest, I've also invested another $100, don't I? Because it's a new month. So let's figure out what this looks like. $200.50 times 1.005 is going to be $201.50. Now that plus the extra 100 I just put away this month, right? Because once again, every month I'm putting away $100. I would be looking at $301.50 in my account right now. Now, isn't that interesting? I've in total invested $300 over the course of 3 months, but now my account is worth $300 with an extra 150, right? Now, this isn't a huge difference, but if we were to continue to do this, right, we would get the following graph. So see how uh, after 10 months, oh, I mean, sorry, my bad. This is years. After 10 years of doing that, every month putting away $100, I'd have 16,000 and about $400. After 20 years, I would have 46,204. And after 30 years, I have 100,451. Now let's look at something here. If I spent 30 years depositing $100 every month, so that's 30 times 12 is going to be 360 times $100 a month. That means I've in total put away $36,000 over the course of 30 years. But look at how much my account is worth. It's worth 100,000. It's gained so much value over this duration of time because 30 years is quite a long time. This is what's known as future value of an annuity. This idea where I'm investing a set amount every period of time. And so my account is not only gaining value from me putting in the money, it's also gaining that interest as I put more money in, right? So the formula for future value looks like the following. F of V, the future value, right? So that's the value of my investment at any given time in the future. It's equal to C, the cash flow per compounding period. That means the amount of money I'm investing each period of time. In this example I did, my compounding period cash flow was 100, right? So the future value is equal to 100 per month times 1 plus R. R is my rate per compounding period. So it's not my annual rate, guys. That's an interesting thing here. R is my rate per compounding period. So because I'm doing monthly, I had to take my 0.06 divide by 12, and that gave me that R was 0.005, and that's why I kept multiplying by 1.005, right? Okay. So we have 1 plus 0.005 to the power of n, where n is the number of compounding periods. Okay. Minus 1 all over r. Well, once again, that's 0.005. Now this is a crazy kind of formula. It looks complicated, right? But really, guys, it's not too crazy. It just has a couple of variables for us to plug in here. All right. I have, and this here gives me my predictions. So if I was to plug n equals how many months is in 30 years again? We said 360. So if I plugged 360 into this formula, I should get the future value is equal to 100,451.504. And if I do that in my calculator, boom, I get the same thing. Okay, cool. Now, let's do another example here. So to close things off about this, guys, we're going to go ahead and talk about, suppose I invest $1,000 per quarter over a 15-year period. If the money earns an annual rate of 6.5% compounded quarterly, how much would be available at the end of the time period? How much is the interest earned? Now, to start things off, let's go ahead and actually move this up a little bit so that we can see. Actually, we'll just copy paste this down here. Let's go throw this guy down here real quick. We don't need that stuff. We'll keep this here for safekeeping, right? Now, I'm going to be solving this problem here, but I'd like you guys to try it out. Try setting it up. Pause the video and try your best to set up the equation, all right, as best as you can. All right, so now I'm going to resume. So we're calculating future value. So the future value of this account here is going to be equal to the C. That's the cash flow per compounding period. That it was $1,000, we said, times 1 plus the rate. What's my interest rate? It's annual rate of 6.5%, but I'm compounding quarterly. So I know that my rate is my interest, my annual interest, divided by how many times I compound. That's 4 for a quarter. Now, the question is, what is 0.065 divided by 4? It's equal to 0.01625. So I've got 1 plus 0.01625. That is raised to the power of n. Ooh. What was n? Oh, look. It's a 15 years. How many quarters are in 15 years? 60, right? 15 times 4 is 60. All right, cool. Keep going with the formula. Minus 1 all over r. That was 0.01625. If I plug this all into a calculator, I will get that my future value is $100,336.68. It asks us then, how much is the interest earned? Basically, how much have we earned in interest? Well, how much did I invest? I invested $1,000 per quarter for 15 years. That's going to be $1,000 invested 60 times, right? There's 60 quarters in 15 years, which would be $60,000. So, how much interest did we gain? Let's subtract it. It looks like $40,000, 336 and 68 cents. And that is calculating future value. Now, guys, future value is really useful for doing things like retirement accounts, right? Like I myself put away money every month for my own retirement, and I've used these future value formulas to try to get an idea of like how much do I want to invest per month and stuff like that. But it goes beyond that, guys, and we will be exploring the applications of this in the future.